So today we are in class 2 of BGP session. Okay.
Yeah.
So today we will start with one of the most important path attributes of BGP, AS path attribute.
Yeah.
BGP AS path attribute. What is AS path attribute? It lists the AS numbers that describe the inter AS path to a destination. Suppose this is AS10, AS11, AS12 and AS13. We have a destination, suppose 192.168.10.0/24 at AS10. So the information of this route is advertised to AS11 and the AS path is 10. AS11 will advertise the information of this route to AS12. So the AS path will be the same thing will happen at AS12 when it advertises the information of this route to AS13. It will be so this is the AS path. This is the AS path from AS13 to the specific destination 192.168.10.0/24. AS path attribute has two major functions. Number one, it is used to select shortest AS path. Number two, it is used for loop avoidance. This is the two major function of the path attribute AS path attribute. So first we will describe how the shortest AS path is determined. Shortest AS path determination. Suppose we have AS 1, we have AS 6, we have AS 3, we have AS 5, we have AS 2, and we have AS 4. AS 1 have a prefix 10.1.1.0/24. So AS1 will advertise about this prefix to AS6 and AS5. So the AS path will be 1. Here it will be same 1. AS6 will advertise this prefix to AS3. Here it will be
AS2.
AS3. Here it will be 6 and 1. And AS5 will advertise to AS2. AS2 will advertise it to AS4. The AS path will be 251, and AS4 again it will advertise to AS3. Here it will be
actually 251 তারপর 4251 এটা একটুখানি বুঝিয়ে দেবেন এটা কিরকম ভাবে আসছে
when AS1 advertise this prefix to AS5, the AS path is 1.
1
Actually AS1, the edge router of AS1 include the AS path with this prefix. When AS5 advertise this information to AS2, it will prepend its AS number. So 5-1, when AS2 forwards the information to AS4, it will prepend its information, prepend the information of AS number 251 the same way. Clear?
ওকে ওকে হ্যাঁ 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 এবারে বুঝতে পেরেছি এবার নেক্সটে ওই 425 বা 11 করে হয়ে যাবে হ্যাঁ ক্লিয়ার
So now AS3 has two paths to reach 10.1.1.0/24. Path 1 through AS6, which is the AS path attributes is 6 and 1, and path 2 through AS4, that is 4251. This is the AS path list. So AS3 will choose the shortest AS path AS3 will choose the shortest AS path. That means it will choose this path. Any doubt?
No, sir.
So we can say AS chooses shortest AS path to destination AS numbers are prepended to AS path AS path attributes provides a sequential information or description of the inter AS path to the destination, and then only AS border router prepares its own AS number to an advertisement and that's why we can say BGP is a path vector protocol. Here path means AS path list that describe the path through AS to destination. So is it clear? Now we'll discuss this point again and this point once more. AS numbers are prepended to AS path. What does it mean? AS1, AS2, AS3, AS4, AS5. Here we have a prefix 10.1.1. This is the software type. So when the information of this prefix is advertised from AS1 to AS2, the AS path will be 1. But when the same information is advertised from AS2 to AS3, the AS path will be 2, 1, not 1, 2. Okay? Not 1, 2, 2, 1. When AS3 advertises the same information to AS4, it will be
3, 2, 1.
3, 2 and 1. When AS4,
4, 3, 2, 1.
yeah, 4, 3, 2 1. So this is how the AS numbers are prepended to an AS path list. Is it clear?
হ্যাঁ স্যার
Any doubt?
হ্যাঁ স্যার
Now the second point, only AS border router prepends its own AS number to an advertisement. That means suppose it is AS1 where we have R1, R2 and R3. It is connected to R4 which is in AS2. Here we have R5, then we have R6 in AS3. Suppose the prefix 10.1.1.0/24 is in router 1, a directly connected route. But here the AS border router, this is the AS border router. When this router advertise the information of this prefix to R4, only then AS path information is added. It will be more clear when we discuss IBGP. Now R4 will inform this information to R5, but without adding any AS number. But when R5, it is also an AS border router. When R5 will inform the information of the route to R6, it will add its own AS number, or we can say it will prepend its own AS number. Any doubt?
না স্যার
Now we will discuss loop avoidance by AS path list. Suppose it is AS1, here we have prefix 10.1.1.0/24. AS2, AS3. So AS1 will advertise the information to AS2 about the prefix 10.1.1.0/24 with its AS number. AS2 will inform the prefix information to AS3. Same way, AS3 will inform to AS1. Now, what will happen? AS1 receiving the information of this prefix, of prefix 10.1.1.0/24 from an external peer. We know external peer means the peer is in different autonomous system. Any doubt? When the information of any prefix is received from an external peer, the AS path is examined. When AS2 receives the prefix information of 10.1.1.0/24, AS2 will examine the AS path. Okay, it is 1. Same thing happen at AS3. AS3 will examine the AS path because it is received from an external peer. Same thing will happen at AS1 because it is received from an external peer. 3, 2 and 1. And AS1 will see its own AS number, in AS path list. Its own AS number at AS path list. Is it clear? So if the receiving router sees its own AS number in the AS path, it will drop the route. It will drop the route. It will drop the information. This is how loop avoidance works in BGP with the help of AS path attribute. Clear? Any doubt?
No, sir.
So now we're going to start about something very basics of eBGP, but before that we have to understand some basic concepts of BGP also. Some basic concepts of BGP also. Start. Every BGP session is point to point. Every BGP session is a unique point to point session, is better to say an unique point to point session. Why? Because BGP is generally used to establish session between untrusted peer. R1 in AS10, R2 in AS20. R2 is administratively controlled by different administrator. R1 is administratively controlled by different administrator. To R1, R2 is unknown. To R2, R1 is unknown. So they are untrusted to each other. So if there is another router R3 which is in AS30. It is also an untrusted peer to R1. So the BGP session between R1 and R2 is a unique point-to-point session. The BGP session between R1 and R3 is a unique point-to-point session, a different point-to-point session. Clear?
No, sir.
Any doubt?
No.
Next point. BGP sessions are always unicast. BGP sessions are always unicast because suppose it is R1 and it is R2. It is in AS10, it is in AS20, it is suppose 12.0.0.1 and it is 12.0.0.2. When we want to establish a BGP session between R1 and R2, we need the unicast IP address of the endpoints. We need this unicast IP address of the endpoints. These IP addresses are unicast. We need these unicast IP addresses. So BGP sessions are always unicast. Next point. Separate session must be established between any neighbor pair. And obviously specified by unicast IP addresses of the neighbor. What we see in IGP? What we see in IGP? We see either multicast or broadcast. IP addresses are used to discover any neighbor dynamically that sharing a common subnet on an IGP enabled interface. R1, R2, if we enable OSPF on this interface, multicast IP 224.0.0.5 is used. by R1 to discover any neighbor that sharing a common subnet on that interface. If R1 receives any messages from R2, then it will form neighborship. But in case of BGP, separate session must be established between any neighbor pair, and that session must be established by using the unicast IP addresses of the neighbors. Okay? Any doubt?
No.
If we think about BGP in this scenario, R1, R2, R3, S30, S10, S20. We need to establish a separate session between these two. We need to establish a separate session between these two. And to establish all these sessions, we need the unicast IP addresses of the endpoint of neighbors. Clear?
Nothing.
Now, the point is BGP runs over TCP and it uses well-known port 179. Generally, IGP runs at layer 3. OSPF, ISIS, EIGRP, IGRP, all runs at layer 3. RIP, uses UDP at layer 4. But BGP runs over TCP and it uses well-known port 179. But what is the advantage of using TCP by BGP? By using TCP, BGP makes its session more reliable. Why? BGP sessions are more reliable because we know TCP provides acknowledgement, TCP provides retransmission, TCP provides sequencing. These make the BGP sessions more reliable. This make the BGP session more reliable. Any doubt?
No.
We have two types of BGP sessions. One is eBGP, that is external BGP. External BGP means a BGP session between neighbors. Those are in different AS. R1 and R2. R1 in AS10, R2 in AS20. So when we establish a BGP session between R1 and R2, that BGP session will be eBGP. And another is iBGP. Internal BGP. A BGP session between neighbors, those are in same AS. Suppose R1 in AS10 and R2 are also in AS10. So when we establish a BGP session between R1 and R2, that session will be known as iBGP. Clear?
Yeah.
Any doubt up to this point?
Yeah, sir.
So now we're going to start a basic eBGP configuration. Okay.
Yeah, sir. সাউন্ডটা আসছে না স্যার।
It is 12.0.0.1/24
হ্যাঁ হ্যাঁ
and it is 12.0.0.2/24.
হুম।
So first we have to configure the IP addresses, interface serial 1/0, IP address 12.0.0.1, no shut, exit. Interface serial 1/0, no shut, so in R1 our first step is router BGP. Suppose R1 is in autonomous system 10 and R2 is in autonomous system 20. Both are in different autonomous system. So our first step is to start the BGP process with its local ASN, router BGP 10. It starts the BGP, this command starts the BGP process with ASN 10. But if we want to start another BGP process with different ASN, it will not. Suppose we will write router BGP 20. BGP is already running, AS is 10. Clear? Our second step is specify the neighbor with its unicast IP and the remote AS of that neighbor. At R2, router BGP 20, neighbor 12.0.0.1 and remote AS, here it will be 10. So we have a log message, neighbor 12.0.0.2 is up. Mind it, BGP can be configured between any combination, private and public autonomous, between private and public autonomous system numbers, between private and public IP address. Okay. eBGP assumes, so the BGP session established between these two routers is now eBGP session. eBGP assumes that neighbor is always directly connected. eBGP assumes neighbor is always directly connected. You can say this is a default behavior of BGP, but we can change it We have some features called eBGP multi-hop. We'll discuss about that later. Okay.
Okay.
So once the BGP session is up, we have a log message. We have a log message in both the routers. Now, we'll discuss something about BGP authentication. Mind it, every eBGP session should be secured because it is between untrusted peers. Why do we need BGP authentication? If it is asked, you have to say that every eBGP session should be secured because it is between untrusted peers. eBGP sessions are between always untrusted peers. Second point, we can say eBGP router is a public facing router. So it is a primary target for attackers. A router that is running eBGP is obviously a public facing router. Any doubt?
No.
So a router which is connected to a public network must be the primary target of any type of attacks. BGP uses MD5 authentication. And we should use separate password for every eBGP session. We should use separate password for every eBGP session. If we have 4 different eBGP sessions, then we must use separate 4 different passwords for every session. So how do we configure authentication in BGP? Router BGP 10, neighbor 12.0.0.2, password suppose I love BGP. You configured a password at R1. Configure terminal, router BGP 20, neighbor 12.0.0.1, password I love BGP. Let's check connectivity between R1 and R2. BGP is very slow routing protocol, that why it is taking some time. Otherwise, when we configure the password at R1, the BGP session should go down. Still it is saying it is up. No router, BGP 10. No router, BGP 20. Router BGP 10. Never 12.0.0.2. Remote is 20. Router BGP 20. Never 12.0.0.1. Remote is 10. Now the session is up. Now configure the password never 12.0.0.2. Password I love BGP. The BGP session should go down between R1 and R2 because I have configured password at R1 only. Wait for some time. It is still up, but it should not be. Let's change this to routers. Interface serial 1 by 0, no sharp. IP address 12.0.0.1. Router BGP 10, neighbor 12.0.0.2, remote AS 20, router BGP 20, neighbor 12.0.0.1, remote AS 10. BGP neighbor is up. Now configure the password. Neighbor 12.0.0.2. Password I love BGP. show process CPU. It is taking too much time. Because we have configured BGP password at one end in R1 and we haven't configured BGP password in R2 yet, so it should goes down. Show IP BGP summary. Still it is showing up, but it should not. Debug IP BGP. So what will happen, let's discuss theoretically. R1, R2, R1 in AS10, R2 in AS20. So we have an established eBGP session between R1 and R2. So when we configure at R1 neighbor 12.0.0.2 password, let's say XYZ, BGP session goes down between R1 and R2 and a log message will generate. Okay. After that we'll configure the same command at R2. Neighbor 12.0.0.1 sub password, same password XYZ. But after configuring this, the BGP session will not come up dynamically. The BGP session will not come up dynamically. But now password is configured at both ends. Okay. BGP session must be reset. Why? Any configuration changes in BGP is required to reset the BGP session. Clear? Any configuration changes in BGP is required to reset the BGP session. It is the configuration change in BGP. It is also a configuration change in BGP. So session must be reset by using this command, clear IP BGP Actually, this command clears all BGP sessions of a router. Clears all BGP sessions. Still it is up. Still it is up. So I hope the concept is clear. So if we now see show running config section BGP. What is this? Show running config. So now check it out. We have entered this command, we have entered this command, and we have entered this command. But we haven't entered this command. We haven't entered this command. We haven't entered this command. These are default commands. these three are default command. Clear?
Default commands.
So we'll discuss one by one the purpose of all these default command. So now, what is the purpose of this command? Any change in neighbor state in BGP must be logged. If there is any change in BGP neighbor state, that will be logged. Still it is up. Still it is up. So I think up to this point everything is clear. So we'll start again with authentication process from our next class. Okay.